So, hey there, everybody. Nice to see ya. And it is episode 11 of Project 2 of The Joy of Functional Game Dev. Here we are on the GitHub release for start of episode 11. The tag is v0.10.1, which is the start of episode 11. And I did a couple of things I added. It wasn't a whole lot. Yesterday I was working on, for the last episode, I was working on things for setting color key. I now have one for getting the color key. And I just started going down the list of the functions that have not been implemented that come from SDL Surface, from Surface.h. And a couple of them I marked as to do because I'm like, I don't want to monkey with that right now. I'm down through the color mods and alpha mods and still have to do the blend modes and whatever else I want to do with the converts. And certain ones like fill recs, I don't see the need to do that. Why don't you just fill multiple? We'll just call this one multiple times. I don't know. But so anyway, the place where we left off is we have an ASCII grid that will have one color for the background and one color for the foreground for each of the cells. And let's go over to Trello. And so we got colors. Yes, we did. We got colors squee for us. Throw that over here. Tile grid. So I want to be able to define an arbitrary grid of tiles, and I have to define what information is in a tile. And let's do that. So that's in our application itself, and actually in our renderer itself. Actually, it's in our game state. So, game state, we had X and Y position because we were moving some stuff around. And that will no longer suffice for what we were doing. So, one of the things that we want to do is we have to define a tile location. So, tile grid, we want to define a tile location. So, tile location, or call it a cell. So a grid is divided into a number of columns and a number of rows. Each location is a cell. So I want a cell location equals, and we want a column, which is an int, and a row, which is also an int. But more than that, I want a measure called type cell. And I want this to be in cells. You may have noticed I do a lot with measurement units, and that's because I feel we're doing math here, and math requires units, and these things are useful, and we're not going to screw it up. We're going to combine pixels and cells. We might have a pixels per cell. As a matter of fact, we may do that. As a matter of fact, let's have pixels per cell. Go let pixels per cell equal, and I know that's 8px per cell. And now we have a really cool factor we can multiply our cells by and get the location. As a matter of fact, we may just do that. We probably will in our renderer. And that's exactly why we do this. So if it were different per vertical cell or per pixels per column, pixels per row, it's actually, that's not a bad pixels per column and pixels per row. And that way we can vary them independently. So how cool is that? So we have a cell location, and then we have type cell equals, and we have here we're going in the round font. We have 200. We have 16 rows, 16 columns, 0 through 255. So we have for lack of a better term, a character byte. Now I also want so I want to do a palette, but not exactly a palette. Shall we? I'll let you know what I mean. So we're gonna do a type cell color. We're gonna make this. We'll even go over to Wikipedia EGA colors. Enhanced graphic adapter. We're going to do carrier. So black, blue, green, cyan, red, so on. And these are just bright and whatever. And here are the hexadecimal values. So how cool is that? Alright, so black, blue, green, red, so on. We got black, blue, green, red, cyan. We'll actually give these values equal 0, equal 1, equal 2. Make it an actual enum. This one's magenta. This one is, what do we call that one? That one is called brown. That is one of the weird ones, brown. We call that one white, or like, we're going to call that one white and bright white. We're going to go with bright black. We're not going with, okay, it's going to be called white, and that one's going to be bright white. That one's going to be, then go with the first color. White equals 7. Dark gray. Bright blue is 9. Bright green equals 10. We're going to do this the smart way. Got that one already. Brew it bright. This one is called yellow, I believe. Double check. So bright blue, green, cyan, red, magenta, yellow, white. Change some numbers here. And why am I picking this particular set of colors, you may ask? Well, this is, we're using ASCII Graphics, and we're kind of emulating a DOS screen, sort of. And why are we doing that? Because for me, this is a new constraint. So I'm not, for one thing, I'm not an artist, and here are a bunch of graphics that I can use. I can also write text on the screen, and I can play with these graphic characters. Also, if I really feel like it, I can modify this bitmap and say that these characters here are really a different look. I've got the freedom to do that, and I've just got the limitation of I have 2 colors on the screen at a time, and it gives me constraints so that I don't sit here going, what do I do? I'm making a grid. They have a character that's a byte, and they have a foreground, which is a cell color, a background, which is also a cell color, and now there's a cell. So and then type, for lack of a better term, call it a cell map, and that's a map of cell location to cell. And how super duper awesome is that? So now I just use the map things, and we're actually now going to do put this in here. It's going to be a cell map called grid. It's a cell map. Because we'll have more to do. So, of course, now game state. Actually, what we type play state. Do this. Okay, so this is going to be a play state. Type game state equals play state of play state. And we're cool with that, right? So I want to immediately get to the play state has these other things associated with it, and it may have other stuff going on, but that's even though that's all there is right now, there will be more. So in render, do I have a state? I have a state somewhere, right? State doesn't even get used now. All right. So now, well, for one thing, let's make a game state. So, all right, here we are in the program, and how do we start? This probably doesn't build, because somewhere up there I got to be initializing the game state, right? Exactly. So there we are. So we need our initial state. Let initial state equal game state game play state map.empty. Have that. We gotta do grid map.empty. Are you cool? You know what? I gotta bring game state in, don't I? Sure do. Open game. Well, I'm opening game state. What? Oh, it's equal. Equal. Alright, so now the initial state goes into here. And perhaps I do initialize the state. Similar to well, hey, let's do this. For equals 0, 15. Do for x is y x in is for y in 0 to 15. Do. Nope, don't like it. Alright. Because that's not how we do that. We're going to fold it. To start, I go to work all day, and I think imperatively. Now I have to think functionally. It's an interesting thing to switch between these things, because now what I want to do is I want to sequence fold course, that's a column. Perhaps it does some nothing, and I take the initial state. Fun column, and so I have to take a state. State column, and give me back to state. So we're going to fold it forever. So I want to take map.empty. Can I put a thing here? Empty. Map.empty. That's cell location. Cell. So I've got the state and I've got a column. What I next want to do is do the same thing. Sequence fold. Fun state row. State. And state. Okay, so there's some fun. Is this weak? so the state here goes. I don't wish. Okay, so state. Call this inner state. Call this outer state. Okay. Inner state. Outer state. The inner state becomes the inner state. Just so I don't get confused. Sure. Yeah, could I do a for loop? Sure I could. This is the outer state that goes here. Okay, so the outer state goes to the fold, and this inner state does this. Really all I'm doing is I'm saying let location equal column equal column times 1 cell, row equals row times 1 cell. So there's our location. We're going to let cell value equal and character equal column plus row times 16, and that has to be made into a byte. Foreground equals column, have cell color, background equals row, cell color. What's going on here? Did I do it wrong? Foreground. Why didn't you guys tell me? Foreground. What's a foreground? So then, initial state should have oh, yeah, it's an enum. Okay. Now we go to cell color. Foreground to cell color. So now I got cell and so now I got the interstate map dot add. What does it take? It takes a which is the location AB. So we're going to take location, cell, adding it to the interstate, and that's the fold. Then goes through to the outer state, and then it should be completely filled up. We will double check this just to be sure. I think I'm right. This expression was expected to have type something or other. What type was this? Oh, right. That's the initial, well, this initial grid. And that's going to be grid equals initial grid. Alright. Don't you like game state? Oh, do that. Alright. So we set the grid on the play state into that, and then we set that onto the enum, to the union case. We'll put this back here and work. Alright, and what does initial grid have? Has all these guys. So brown, 60 black. So cool. Alright. We're going to keep going. And it's still doing that, but that's where we're about to stop it doing. In our renderer. So we don't need random anymore. We don't need we still probably need that though. We need these things. Okay. So in our not switch, match state with play state game state in there. So I've got play state, and that's a play state. So state dot grid map dot it's not for all, it's iter on cell does some nothing. Expression was expected, so it's location cell unit. So I got the location. So I got where it goes. So these things are out. I will, however, need something to map my render colors. So let's make that right quick. I'll let palette, this can be private, equals, it's going to be a list, so it's going to be a sequence, and we're going to have, cell color dot black. So we're going to make this super simple, because I don't want to be doing this all day. Alright. Okay, get rid of that. Okay, I still do things, some of the things in my old way. So leave me alone. Oh yeah, I do need cell color, don't I? Now let's do comma chameleon. Can I do this now? Will this allow me to do that? It does. So what happened? Oh, I like it. Red equals 0x00, green equals 0x00, blue equals 0x00, alpha equals 0x00. Do I have to UI them? I think I do. Alright, now over to there, and a comma. So, this is going to be awesome. It is going to be awesome. Look at that. My goodness. Alright, let's go back over to the wiki. So, blue happens first, so every other one is AAA until we hit this, which is either 5.5 or FF, 5.5 or FF. Alright, AA, 5.5, FF, 5, FF, 5, FF. Green does 2, so 0, 0, AA, 0, 0. Oh, that one's 5.5 and AA. So this is the weird one. So, oh, nope. Don't forget to Alt AA. All right. So this one is going to be a 5.5. FF. 5.5. finally, it's 0, 0, 0, 0, A. So 4 zeros, 4 A's, 4 5's, 4 F's. 1, 2, 3, 4. 1, 2. Okay. 1, 2, A. All right. So now we got the colors. We got the palette. I'm going to do map of sequence. Oh. Remember, kids, semicolons. Now the palette is map of cell color to color. Exactly what I want. So, what I want is, see, awesomely, these map to exactly what we're doing here. Just rather than random, this one is cell dot character. And this one is the palette dot cell dot foreground. And naturally this one's cell dot background. So sprites is int to sprite. Where's my where are you? I don't want a map of int to sprite. I want a map of byte to sprite. And that's going to cause a problem. Doesn't contain a field called random. It's true. Got rid of you. Can I do UI to 0255 UI? Will this work? Hey, it does work. And I got some angry compiler going on. The type int doesn't match the type byte. No kidding. So I think for this case we're just gonna have to do index go to int. Because it's going to otherwise it's going to pitch a fit. Alright. Background. Constructor X. What is X? Well, I need X. X is going to be... Actually, no. That's location. It is location dot column times pixels per column. Location dot row times pixels, pixels per row. And we'll even do this. We're going to go one cell times pixels per column. One cell times pixels per row. See, so what's nice here is we have absolutely no, well, there's still some hard coding in here somewhere. But right now, if I decided I wanted to bullet it, what my, oh, I'll do that again. Nope. What are you? What are you? I think I need, this is being used more than once. I think this needs to be stored in a different, it needs to be bound to a different symbol here. Well, there we are. All right. And that officially worked. So we've got all the characters, and some of them are invisible because the same background is on the same foreground. Most notably, well, also black doesn't work. So that's our main. That's our major problem. We can make it. We could make it work, or get closer to working. Yeah, as a matter of fact, I think I want to do that. Maybe I'll make, because really, in the end, what is the difference between 0 and 1? What's the difference? What is the difference? Can you tell the difference? No. As a matter of fact, then you can actually see these. So we're going to have it just barely off so that we can see our black graphics. But we're not actually using black, it's almost black. The ones right down the diagonal is the same color foreground and background. So we can do this all day. And we could even have we could redo our random thing, but let's instead think about what it is we want to do here. So now, so this right here, this is no good at all. This is too long. This is something that should be composable. Because what are we taking? We take a work surface into there. We take a sprite. We plop it onto the work surface. Although this is the only place where it has to happen, so it's actually perfectly okay. Well, for lack of anything else, well, we got the tile grid. We got the tile grid done. All right, label tile grid squee. So now we have a grid of tiles. We can render onto them whatever we wish. We're gonna go let strect equal that because I don't like it. Direct. I don't like being the same thing over and over. There, that makes me feel better. It was bugging me. Don't have the same thing twice. You have to double your maintenance and double your fun. Don't do that. Yep, there's that. So, all right. And is this the right place for the palette? It's fine, because it's the only place you use it. These sprites, this has got to get moved out. That's for sure. Alright, for today, I think we got it. Thanks for coming on this journey with me. And as always, try to keep the joy of functional game dev in your heart. We'll see you next time.